Welcome you all. Our today's topic is the brief introduction of transmission line. At the end of this lecture, you will be able to understand the transmission lines and its classifications. Generally, when we talk about the transmission line, then obviously it comes in mind about the electrical transmission line for transmission of electrical energy from one point to another distant point through a long and dedicated distributed network. In most of the cases, the transmission line is defined as a conductive method of guiding of electrical energy from one place to another with minimum loss or distortion. In communication engineering, we find that it is a specialized cable for conducting alternating current of radio frequency signals. In microwave communications, we use the waveguides for conducting the electromagnetic signals. Also in optical communications, we use the optical fiber as a waveguide. So, in general, the conductors and the waveguides responsible for transmission of power or energy from one place to another are commonly known as transmission lines. Generally, circuits and networks are made up with two types of items. Some items that perform operations on the signals called components, and some other items that only carry signals from one point to another with minimum losses or distortion of the signals called transmission lines. So the components which are responsible for the transmission of signals are called transmission lines, and they come in various sizes, shapes and forms. In this slide, we have discussed about the different types of transmission lines, namely the two-way line where two conducting wires run parallelly. The coaxial cable, it is basically a hollow tube with another coaxially located cable inside it. And next, the waveguide. A waveguide is a structure that guides waves such as electromagnetic waves, sound waves, etc. with minimal loss of energy by restricting propagation in one or two dimensions. There are different types of waveguides for each type of wave. The original and most common is a hollow conductive metal pipe used to carry high frequency radio waves, particularly microwaves. Waveguides in microwave is an electromagnetic feed line used in microwave communications, broadcasting and radar installations. It consists of a rectangular or cylindrical metal tube or pipe. The electromagnetic field propagates lengthwise. These waveguides are most often used with horn antennas and dish antennas. Whereas an optical waveguide is a specially inhomogeneous structure for guiding light, that is for restricting the spatial region in which light can propagate. Usually, an optical waveguide contains a region of increased refractive index compared with the surrounding medium called cladding. The frequency of the transmitted wave also dictates the shape of the waveguide. That is, an optical fiber guiding high frequency light will not guide microwave of a much lower frequency. It is also interesting to note that some naturally occurring structures can also act as waveguides. The SOFR, that is short for sound fixing and ranging channel layer in the ocean can guide the sound of whale song across enormous distances. This slide shows the different form of two-wire line, that is the parallel wire type transmission line. It is so named because of its construction. The two wire of the transmission line are twisted to reduce interference and radiation from discontinuities. For example, the lateral line, twisted pair, ordinary telephone line, etc. belongs to this group. It is a balanced line. This slide shows the different type of coaxial cables. In this type of transmission line, one conductor is a hollow tube and another one is located coaxially inside the tube. The dielectric between the two conductors may be solid or gaseous. It is an unbalanced line. The waveguide. In case of waveguide, the geometry is the most important factor. The geometry of a waveguide reflects its function. For example, the slab waveguides confine energy in one dimension. The fiber or channel waveguides confine energy in two dimensions. It may be rectangular and circular type. Waveguides are tubes of uniform cross section for transmission of waves by continuous reflection from the inner walls of the guide. It may be of two types. One is hollow conducting tube used for microwave communications, and another one is solid dielectric type made of glass materials for optical fiber communications. The different shapes and some of the waveguides, optical waveguides and the microwave waveguides are displayed here. Rectangular waveguide, coplanar waveguide are most common type of waveguides. Now, we will discuss the planar transmission lines. The strip line, microstrip line, slot line, fin line, coplanar waveguide, coplanar slot line. All this belongs to this group. All these types are available commercially in different sizes. This slide shows the different kind of planar transmission lines. Geometrical structure of different type of planar transmission lines are shown in this figure. Some cross-sectional views are also shown here. Next, we will focus in the properties of transmission lines. Transmission lines are having two conductors that run parallel. Theoretically, any frequency can propagate through the transmission line as a signal. At high frequency, it becomes more lossy. Normally, it is used to handle low or moderate power. Signal distortion normally do not take place unless there is any loss. This slide shows the transmission line in general. Now we will discuss the properties of microwave waveguide. Microwave waveguide is a single hollow metal pipe. The signal propagates through this waveguide when the frequencies are higher than a critical value. Signal distortion takes place even in the lossless cases also. Normally, it is immune to interference. Microwave waveguide can handle large amount of power. As compared to transmission line, it has low loss. This slide shows some microwave waveguides which are very common in nature. Now, we will focus on the properties of optical waveguide. Optical waveguide is a dielectric rod made of glass material. Theoretically, any frequency can propagate through this optical waveguide. It has negligible loss. Signal distortion is also minimum in case of optical waveguide. It is very immune to interference. It is not suitable for high power transmission. Fiber optic waveguide is shown in this slide. As we have already discussed that the light wave as signal propagates through the optical waveguide. The total internal reflection takes place during this propagation. Here, the optical fiber acts as a waveguide. We are concluding here. Thanks for your patient hearing. I feel you have learned something going through this lecture and presentation about transmission lines. In the next lectures, we will focus in details of transmission lines. Thank you.